These are some high-yield amino acid facts that I see tested all the time on the MCAT. The first group of amino acids are the serine, tyrosine, and threonine hydroxyl-containing amino acids, right? So these have side chains with hydroxyl group. First of all, they can donate hydrogen bonds in their side chains. And then more importantly, and what's often tested on the MCAT, is that these are targets for phosphorylation. So protein kinases will add phosphate groups to proteins specifically at serine, tyrosine, or threonine, specifically their hydroxyl group. The next group are the aromatic amino acids, tryptophan W, tyrosine Y, and phenylalanine F. Okay, so because they have a lot of conjugated pi electrons, these actually absorb ultraviolet light at 280 nanometers wavelength, okay? And that can actually be used to detect proteins in a sample. Now, this is in contrast to nitrogenous bases in DNA and RNA, which actually absorb UV light specifically at 260 nanometers. Next, we have the acidic amino acids, so aspartate D and glutamate E, okay? These have carboxylic acids in their side chains, and they are usually deprotonated and negatively charged at physiological pH. Then there's the nucleophilic amino acids. These are serine, threonine, cysteine, lysine, and tyrosine. Now, because they're nucleophilic, they can actually be used for nucleophilic covalent catalysis by enzymes, where they form a temporary covalent bond to a reactant in the active site, okay? And a good mnemonic to memorize these is sticky, okay, like the word sticky, STCKY, which corresponds to the one-letter abbreviations for these nucleophilic amino acids. Now, serine is actually found in enzymes proteases such as trypsin, chymotrypsin released by the pancreas. Cysteine, for instance, is found in cysteine proteases such as caspases involved in apoptosis. And lastly, we have histidine H. So this is the side chain of histidine, okay? This is an imidazole ring. It's actually aromatic and it's heterocyclic because in addition to the carbons in the ring, it also has these nitrogens. Now, as it turns out, this nitrogen that is deprotonated here can actually accept a proton and become protonated, and it'll become positively charged. Now, the pKa of this group here is going to be around 6, which is very close to physiological pH of around 7.4. And so at physiological pH, a fairly appreciable amount of this amino acid can be both protonated and deprotonated, okay? And that allows it to be used by enzymes as an acid-base catalyst, where it is used to shuttle protons between reactants in reaction. I'd like to invite you to my live workshop, which I'm hosting tomorrow, Thursday, June 5th at 8 p.m. EST or 5 p.m. PST. In this workshop, I'll be teaching you my 5 most important strategies for scoring a 516 or higher on the MCAT. These are strategies that I've cultivated over years of tutoring students preparing for the MCAT, and many students think that it helped them get really great results. So I really hope to see you there. Please leave a comment and shoot us a DM, and we'll send you a link.